Welcome to lecture 20 of the course CS 213 Object Oriented Programming of the Cohort University of Science and Technology. This lecture will be a little different from what we have been doing so far in this course. This lecture will cover a case study in which we will try to revise the concepts that we have learned so far right from the beginning up to a certain endpoint. A case study is basically where we are given a task and we are required to develop an end-to-end project for that given task. Here we will consider the ATM case study that is taken from one of the older versions of the book Java Deitel and Deitel book. In the first phase, we will examine the requirements document. A requirements document is something that specifies the purpose of the system and what it must do. If you have studied software engineering or if you will study software engineering in any of your future courses, you will understand that a requirements document is something that is given to us first hand when we are required to develop a project or a software for something. For example, if you are required to develop a software for an ATM system, then the requirements document will include all of the details that are required from that software. Now you will have to go through that requirements document and try to analyze your system before you can start programming for that system. So for example, your requirements document states that there is a local bank that intends to install a new automated teller machine, that is the ATM, to allow users or the bank customers to perform basic financial transactions. And those transactions can include, for example, viewing of their balance, withdraw cash, deposit funds, etc. Now, there are certain limitations, and any kind of limitations will be provided to you through the requirements document. This says that each user can have only one account at the bank. Now this might not be the case in real life, but this system requires you to have only one bank account for each user, and those users might be able to or must be able to view their account balance. They should be able to withdraw cash from the ATM, and they should be able to deposit funds through the ATM. Now continue our examination of the requirements document. The document requires you to have the ATM user interface, that is a screen that displays messages to the user. And these can be some informative messages directing the user how to use the ATM machine or how can they get their required functions from the ATM machine. It needs to have a keypad that receives numeric input from the user, as we can see with any ATM machine. It needs to have a cash dispenser that dispenses cash to the user, and it needs to have a deposit slot that receives deposit envelopes from the user. So these are the basic operations of an ATM machine, and whenever you start to develop a software for any task, the first thing that you do is to study their main requirements. What are the main operations that thing is going to do or perform. The cash dispenser begins each day loaded with a certain amount. For example, certain amount of cash is loaded into the ATM machine each day. Now we can see the proposed ATM interface on the screen. Now in our case study we might not we might not make the graphical user interface of the ATM machine. Of course you can improve on that, we will, since we have been working with the console based user interface, and we will be sticking to that interface. But following this lecture we will be moving to our graphical user interfaces, and then you can apply your learned knowledge to developing a graphical user interface for the ATM machine or any other project that you prefer to work on. Now these are the requirements. For example, whenever we go to an ATM machine, in this case we won't have a card since we are working on a simulator environment, in a simulation environment. Our laptop screen or our computer screen will be the screen that we are going to interact with, and the keyboard of our laptop or our computer is the keypad that we are going to interact with our ATM machine. So we'll be displaying all of these details on our laptop screen. Usually a normal ATM machine reads all of the most of the details from our card, and then you are required to enter a PIN for your account number. What we do here is we will enter an account number, the user will enter an account number, and then the user will enter a PIN code that would match that account number, and these details will be verified from a database at the back end of the user interface. Then simulatively, when a cash is dispensed to the user, that amount should be deducted from the user's account or the user's balance stored in the user's account. Then there is a deposit slot, and if the user enters some amount in the deposit slot, that amount should be added to the user's balance in the user's account. There is a keypad that is given. In our case we will be using the keyboard of our laptop or computer. Examining the details further, develop software to perform the financial transactions initiated by bank customers through the ATM. Use the computer's monitor to simulate ATM screen and the computer's keyboard to simulate the ATM's keypad. An ATM session consists of authenticating a user based on account number and personal identification number. So as soon as we start using an ATM, we are required to authenticate our details. That is, if the details or the person interacting with the ATM machine is the right kind of a person using that account details. And this we will do through a very simple verification. We will obviously not consider all of the security details that a functioning real world ATM machine considers. Since we are working on a simulation of an ATM machine, we will require only basic validation or verification authentication measures. Once the user has been identified, the user should be able to create and execute financial transactions through the ATM machine. And for the authentication, interact with the bank's account information database. The information should come from the bank's database. For each account, the database stores an account number, a PIN, and a balance indicating the amount of money in the account. Usually we get our account number through our cards, debit cards or credit cards, but here in this case we will have an account number, enter an account number through the keyboard, and then a PIN that would be verified from the bank's database. Simplifying assumption. For obvious reasons, this is a very simple assumption, a simplified assumption of an ATM machine. The bank plans to build only one ATM, so we do not need to consider the network or the vast network of ATMs that can access the bank's database at the same time. The bank does not make any changes to the information in the database while the user is accessing the ATM. Now, there can be issues when and those issues can be covered, for example, in the concurrency. But since we are not studying database and we are not studying trying to implement the complete system of an ATM, so we assume that the record of the user is not accessed by, for example, at the same time by the user and the bank. The bank trusts the ATM to access and manipulate the information in the database without significant security measures. Now, accessing and modifying financial details would require very hard kind of security measures, but since we are working on a simulation, we won't be considering those details. Our focus will be on the programming side, the basic programming side of the ATM machine that will simulate an ATM machine on our computer's screens. Upon first approaching the ATM, the user should experience the following sequence of events. There should be a welcome screen that displays welcome and prompts the user to enter an account number. The user enters a 5-digit account number using the keyboard. The screen prompts the user to enter the PIN, personal identification number associated with the specified account number. Now you can see that these are the details that would be provided to you in the requirements document. As a developer, there might be situations that you are provided a ready-made requirements document and you are required to develop a software according to those requirements. But in some cases, you will have to develop your own requirements document based on collecting data, conducting interviews from the potential users of your software, and prepare a written, well-documented requirements document, and based on that document, you will develop your software. And this can be true for any application or software that you are developing, be that a mobile application or be that a desktop application. The things that you must know is one, that what the users of that application would want, and that is the one of the most important things to consider whenever you are developing an application, and that is something that you do through the requirements document. The user enters a 5-digit PIN using the keypad. Now initially there were very basic or general information about the main idea of your system, and now we are entering into a bit of the detailed requirement of what the system would do or should do. If the user enters a valid account number and the correct PIN for that account, the screen displays the main menu. If the user enters an invalid account number or an incorrect PIN, the screen displays an appropriate message. Then the ATM returns to step 1 to restart the authentication process. Now we have been doing some very basic authentication or validation in our earlier programs. This might be a little more than that, but for any system to work properly, we need to be able to authenticate and validate some kind of data. Now this is the initial screen or menu. In our case, we'll be getting the screen on our console-based user interface. On the main menu, there are 4 options given to the user. The user enters a choice from his or her keyboard, and the following operations should result based on the choice of the user. If the user enters 1 to make a balance inquiry, the screen displays the user's account balance. To do so, the ATM must retrieve the balance from the bank's database. The following steps describe what occurs when the user enters 2 to make a withdrawal. The screen displays a menu of standard withdrawal amounts and an option to cancel the transaction. If you have used an ATM machine, you would have seen that when we enter our PIN code, we are provided with a menu to choose from. When we choose a menu, for example, choose withdrawal from the amount from the ATM, we are given certain options to choose from, and that includes the different amounts that we can withdraw from the ATM. The user enters a menu selection using the keypad. If the withdrawal amount, and again we need to validate, for example, we must have the amount that we are trying to withdraw at least more than the amount that we are trying to withdraw from the ATM machine. If the withdrawal amount is greater than the user's account balance, the screen displays a message stating that this and telling the user to choose a smaller amount. The ATM then returns to step 1. If the withdrawal amount chosen is less than or equal to the user's account balance, an acceptable amount for example, the ATM proceeds to step 4. If the user chooses to cancel, the ATM displays the main menu and waits for user input. If the cash dispenser contains enough cash, now the first validation is the user must enter an amount that is there in the user's bank account. It should not be more than that. The second thing that we need to check that even if the ATM machine has enough cash provide to the user, the ATM proceeds to step 5. Otherwise, the screen displays a message indicating the problem and telling the user to choose a smaller withdrawal amount. The ATM then returns to step 1. We usually face many problems with ATM machines, especially at the start of the month, that they do not usually have enough money to dispense to the users, and you need to pay frequent visits to the ATM machine to get your amount even though you have the money in your account. The ATM debits the withdrawal amount from the user's account in the bank's database. Now debiting simply means subtracting the amount from the user's account. That is an accounting term used for debiting, and that simply means deducting the amount from the user's account. Accrediting would mean adding the amount to the user's account. The cash dispenser dispenses the desired amount of money to the user. The screen displays a message reminding the user to take the money, and some time would be provided to the user for to collect the money. Now this is the screen that you would get when the user enters withdrawal, for example choice 1 that the user wants to, choice 2 that was to withdraw money. The user has a few options to choose from, and the user can also cancel the transaction. The following steps describe the actions that occur when the user enters 3 to make a deposit. The screen prompts the user to enter a deposit amount or type 0 to cancel. The user enters a deposit amount or 0 using the keypad. If the user specifies a deposit amount, the ATM proceeds to step 4. If the user chooses to cancel the transaction by entering 0, the ATM displays the main menu and waits for the user input. The screen displays a message telling the user to insert a deposit envelope. If the deposit slot receives a deposit envelope within 2 minutes, the ATM credits the deposit amount to the user's account in the bank's database. In simple terms, it adds the deposit amount to the user's account balance. In our proposed ATM machine, the users can not only withdraw amount from the ATM, but the user can also deposit some amount to his or her bank account. After the system successfully executes a transaction, it should return to the main menu so that the user can perform additional transactions. If the user exits the system, the screen should display a thank you message, then display the welcome message for the next user. Now to analyze the ATM system further, what we got was in the previous, for example, slides. In the preceding statement is a simplified example of a requirements document, and that was maybe a very simple example of a requirements document. The real requirements document might be very detailed, and that document is a result of a detailed process of requirements gathering. And whenever you develop a software, you are supposed to gather the requirements, all kinds of requirements that software is supposed to perform. What is basically the software going to do? What are the type of the users that the software will help? A system analyst might interview banking experts to gain a better understanding of what the software must do. And this is sometimes you, as a software developer, might yourself be performing the job of a system analyst by interviewing people for whom you are developing your software. Maybe in some situations you will be provided with a developed document, but in some cases, or especially in the earlier cases, you will be working as a system analyst first to gather all the types of requirements that your software is going to perform, or the things that your software is going to do, and you would use the information gained to compile a list of system requirements to guide systems designers as they design the system. And the second stage of the requirements documentation is, once the system analyst has gathered all the system requirements, those requirements are provided to the system designers to guide them to design the system. Now the important or most of the important element of any software development is modeling your system. The first phase should always be developing a model, and based on that model you will be developing a working software for your requirements. The analysis stage focuses on defining the problem to be solved. Once we have all the definitions, when designing any system, one must solve the problem right. But of equal importance, one must solve the right problem. For example, if you are working on a software, you might get the solution, but you must ensure that that is the right solution for the right problem that you are working on. During the analysis stage, system designers focus on understanding the requirements document to produce a high-level specification that describes what the system is supposed to do. As we are repeating this point again and again, it is very important to understand firsthand that what is that you are developing, what will the end product that you have developed should do. And we try to analyze that at our design stage, at a very earlier analysis and design stage. The output of the design stage, a design specification, should specify clearly how the system should be constructed to specify these requirements, to satisfy these requirements. And there are certain models that we can use to develop our, a design of our proposed system. UML2 provides standard 13 diagram types for documenting the system models, and these are the standards that are used by any system designers before they develop a software. Each models a distinct characteristic of a system's structure or behavior. Now you will study these standards or maybe UML diagrams or any other diagrams in a software engineering course, maybe, or in any other course in the future. Here in this course we will only focus on UML class diagram that we have touched previously, and we will, and that is usually the first stage of our software development. And since I said earlier that we will be repeating some of our concepts that we have learned during the course, so we will be starting from a UML diagram. Each models are distinct. Now each of these 13 diagrams models a distinct characteristic of a system's structure or behavior. 6 diagrams relate to system structure, the remaining 7 to system behavior. We will use only class diagrams which model the classes or building blocks used in the system. Now our class diagrams should contain our classes, their variables and their operations. How to identify the classes in a requirements document? For example, we are given a requirements document, and that is maybe a text document where the details of the required software are given to you. Your job as a software developer will be to read that document and try to extract the classes. In the first case, what classes are you going to create in your proposed software? How do we identify the classes? Now there can be hints that are provided within the requirement document. For example, identify the classes that are needed to build the system by analyzing the nouns and noun phrases that appear in the requirements document. In a first case, what you can do is you can pick all of the nouns and noun phrases that are there in the requirements document. These can be your potential candidates for classes. With further analysis, you might include more classes or you might remove some of these details, but as an initial stage, it will provide you a list of your potential classes. We may decide that some of these nouns and noun phrases are actually attributes of other classes in the system. So some of these nouns might be your classes, and some of these might be the attributes of those classes, but you will get an idea of where to start from. We may also conclude that some of the nouns do not correspond to parts of the system and thus should not be modeled at all. You might throw away some of the nouns from the initial analysis, but still you will get to things where to start from. Additional classes may become apparent to us as we proceed through the design process. As we can see, there is a list of nouns that is picked from the initial requirements document, the things that we studied in our earlier slide. For example, we saw that there was the name of a bank, that is a noun. The screen was a noun. The bank database is a noun. Transaction is a noun phrase. A deposit slot is a noun. Money, funds, pin, customer, cash or bill, deposit, account number, user, cash dispenser, withdrawal, balance, ATM, keypad, balance inquiry, account, deposit envelope. Almost all of the nouns and noun phrases from our earlier requirements document have been picked and listed in this graphic that you can see. Now some of these might become our classes, and when we develop the software, some of these might become attributes within those classes, and some we might discard altogether without using them in our program. But from our short requirements document, from our simple requirements document, we have picked these nouns This can be a starting point from where you can start building your system. You can build classes for your system.